Hello students, this is Mr. McAllen again, and this is a third video in our look at inverses. And the first thing I want to talk about is what our objectives are for this. So the first thing we're going to think about is how to find the inverse relation algebraically. Now we're going to do some algebra to find out what the inverse relation would be, but then we'd like to inspect and see if it is actually an inverse function from the work we did with the algebra. So let's start out with an equation. So in our textbook, we're going to have several different examples to use. So let's just start out with something real easy. Let's say that, they say that we have a function and it's equal to 2x plus 5. So we're just using a nice easy problem to kind of get us started. We know that 2x plus 5 has a y-intercept of 5 and a slope of 2. So here it is, 2x plus 5. And so what we do with the steps is we first switch x with y, because remember, that's the most fundamental basic thing that we do with an inverse. We switch x and y pairs, so here we go, we're going to switch them. So I'm going to have x equals 2y plus 5, and then I'm going to solve for y. So when I solve for y, I'll have x minus 5 equals 2y, and then y equals x minus 5 over 2. So this, well, before we call it an inverse function, we want to verify that. So I'm just going to call it y equals x minus 5 over 2. So if I go to Desmos and I plot both of these, you would see that, here, let's just plot them real quick. So I'm going to just kill these old, hold on, let's go to Desmos. So we have y equals 2x plus 5. And now let's look at what the inverse would be. It's y equals x minus 5 over 2. I have to make sure this is in parentheses. And you see that we have, well, let's just zoom out a bit so you can see this. We have that symmetry about y equals x. You can see we have the symmetry across both of them. I could even just zoom out a little more so you can see that. So that, in fact, shows me that I definitely have an inverse relation. And because the red function, I'll just isolate that, because the red function clearly passes the vertical line test, we can call that inverse function. Therefore, going back to our original graph, and I can now call that f of, well, I'll use the inverse notation. So this would be f negative 1 of x equals x minus 5 over 2. That would represent, if I use the f, that would represent that it is in fact an inverse function. So let's look at another one, maybe one where it's a little bit more, not so complicated, but let's just look at one where it is like a, let's call it a rational function. So if f of x equals 2x minus 3, I'm sorry, 2x minus 3 over x plus 1. So we switch x with y. Well, first I'm going to write y. I'm going to now switch x with y. So that becomes an x, and these terms over here have a y in it. Now I'm going to cross multiply. And the idea is I've got to solve for y. So what I have to do is I have to multiply. I have xy plus x equals 2y minus 3. Now this is where it becomes a little tricky. I've got to collect all my terms with y in it because I want to solve for y. So I'm going to have xy minus 2y equals negative x minus 3. So here I'm like collecting like terms. So now I've got to factor a y out, because remember I'm solving for y, and I've got x minus 2 equals negative x minus 3. So I'm going to divide by x minus 2. So I've got negative x minus 3 divided by x minus 2. And now the big thing is I want to check to see, is this actually an inverse? I suspect it's an inverse relation. I want to see if it's going to be an inverse function. And so let me plot that on Desmos just to check it graphically real quick. And so I'm going to pause the video while I put up on Desmos so I don't bore you to tears. Okay, so I'm back and I just put the function in. So the black function here is, I'm going to just go to projector mode so you can really see it. The black function here is the function I started with. It's f of x. So I'm just going to call that f of x. And the function down in number 3 spot is the is what I've calculated. So when I turn that on, hopefully you can see that it does have that symmetry, but it might be tough for you to see that because it is like a hyperbolic function or a rational function. It's kind of tough to see sometimes. But here's the big thing is, like, remember that test I did in one of the earlier videos? I put in, for the function, I put in f of x equals 2x minus 3. So I use f of x notation. So I can easily just do x equals f of y. And you can see how the green line is on top of the red line. That shows that what I solve for in number 3 is, in fact, the inverse that I found through Desmos. So we do have ways to algebraically check for this, and I want to show that to you in class. But just to get going before we get to class, I want to make sure that you know how to actually solve for an inverse relation by just switching x with y, and then you have to solve algebraically for y, and then verify it with Desmos, and then we'll show you a verification with the algebra when we're in class. So I hope this video helps you understand or recall some of the things that you may have known already about inverses and solving for them, and we'll talk more in class. So I look forward to hearing your comments, and talk to you later.